Get started here in this second. Want to make sure Eric's got plenty of time. For the folks online, looks like we've got about 20 people online. Great. So we're at time, so I'll go ahead and get started. Just to make sure that we give Eric the floor soon. My name is Damon Woods. I'm director of the Integrated Design Lab. For those who don't know who we are just upstairs on the 3rd floor. We are a research branch of the College of Art and Architecture at the University of Idaho. So our mission is to educate, and that's why we have lectures like this one. So this is sponsored by Idaho Power. So for a really good lunch from Don and Charlie's, you can thank Jerry Wilhite and Chris Paulo with Idaho Power for sponsoring that today. We have a few different programs with Idaho Power that if you're not aware of, you really should be. One is our energy resource library. So we have about 900 different tools, all for diagnosing how a building uses energy. CO2 monitors, cameras, data loggers for rooftop units, all of that stuff is available for free for you guys to use. Please use it. It's available on our website. Dylan, if you want to go to the next slide. You're here at BSUG, which is awesome. I'm excited to introduce Eric shortly. We'll also have a lecture next month, June 12th, with Katie. What's her last?
Balcom from Building Transparency.
From Building Transparency on the energy efficiency of materials that go into buildings. So that's going to be interesting next month. So put that on your calendars. And then if your firm isn't a part of our Lunch and Learn series, make a request so that you get on our lecture circuit. Once again, it's catered lunch by Idaho Power. You get continuing education credits for it. And we go out to a specific firm, and we've got a list of a dozen different topics that we offer each year, whether you're an architect or engineer or just a professional organization. We can try to cater to your needs as much as possible, all focused on energy efficiency. All right, what's next, Dylan? Next slide. And then, of course, we've got our technical design assistance program. So we're a free help desk, right? We have graduate students who end up graduating. So congrats to Teas and Lindsay, who were previous grad students at our office and are now out in the field. But we now have Gregory, Tavia, Kundo, and others who will go and do research to help your firm. So if you're about to install like a new window film, or you're curious about a new high efficiency heat exchanger, but you don't personally have the expertise or the time to dive into it, that's what we're here for. And so anything less than $2,000 worth of our time, so like a week of our work, is completely free to you guys. If it's going to be about 2 weeks of our time, $4,000, then we submit a 1-page scope of work. Here's what we're going to look into. Here's what we'll deliver to you. And we submit that to Idaho Power for approval. As long as it's commercial energy efficiency, we are good to go, and we'll help you on it. And then if it's going to be a really large project where we're involved in your firm from the very beginning, helping design charrettes, teaching you full suite of energy modeling tools or something like that, then there's a cost share where Idaho Power will pay 75% of our design time, and then the client or your firm will pay the other 25%. So it's still a really good deal on a training resource. We're not trying to compete with private industry. We're just, once again, here to help you guys learn new things, learn about new technologies. All that will save energy efficiency. There are also other Idaho Power programs, and Sheree and Chris, feel free to elaborate if I don't mention it enough. But there's new construction, major renovation. There's some information on the back table on some of those projects, including a new one on multifamily, which is great. And then if you want to go to the next one, Dylan, there's also a professional assistance incentive. So we know it takes a lot of your time to fill out some of that paperwork for incentives. So this is a way to encourage you to do that right at the beginning of the project. So make sure you do it early on rather than after the fact, because otherwise you might not be able to be eligible for that incentive. This is one way to do that. So I'll go ahead and switch over to Eric's presentation here. And, oh, Dylan, can you see that? Probably not. Let me share my screen. Share the screen. Go into presenter mode.
Okay, we can see it.
And I'm gonna move the toolbar here, so Eric, you don't get annoyed by that. Okay. So we have Eric Ringold teaching today. He's been a member of the Boise design community for a while. And he's always been very generous with his expertise. So, and he's also volunteered with ASHRAE. Sometimes you get experts who are just like really gifted at something, and then they're like really unkind humans. And Eric is not that way. So I'm really grateful for him and all the volunteer work and education work that he's done in Boise, including this lecture. He spent over a decade consulting, using his experience in commercial building modeling, new and existing, to meet various certifications, energy efficiency goals. And now he's using that expertise at NREL to both enhance existing energy modeling tools and then develop new ones as well, some of which he'll share with us today. So please give a warm welcome to Eric Ringold. And just a note for online attendees, if you have questions, you can put them in the chat, and Dylan is going to be monitoring that, but we'll probably stay muted. And Eric.
Oh, yeah.
Just about that.
Hi, yeah, I'm Eric Ringold. Like David said, I am actually from Boise originally. I grew up here, graduated from Boise High actually 20 years ago this month, which is crazy. And so, yeah, I was going to talk a little bit about my background, my experience using really like general purpose programming for building energy modeling. I want to talk a little bit about my background because that kind of tells a story about how I got into this from starting as a modeler. Talk about why you might want to use or build your own custom tools as a BEM practitioner, and give a couple examples of stuff that I've developed to solve particular BEM problems, of course, my experience. First, starting with my background, like I said, I grew up here in Boise. In 2004, I went to New York City to the Cooper Union to get a bachelor's in mechanical engineering. We were educated in this pretty uninspiring, like 60s era building. Cooper Union's a small engineering program, so there's like 200 students, so we all fit in one building. I had a pretty typical mechanical engineering education, not a lot of coding as part of that. I took one course in Intro to Computer Science, like freshman year. It was taught in C. I think that's the grade I got in the class. It wasn't like, didn't really jive with me. The rest of the education, you know, I think probably did a little bit of Simulink programming or MATLAB programming, and but really nothing too in depth. I didn't feel like it was for me. Like I didn't really get the concepts and didn't really understand. Anyway, so I graduated into the Great Recession. That was fun. Spent a couple years doing other stuff, working in grocery stores and you know, for the Census Bureau, things like that. It was fun times. I got my first job in like 2011, and then I actually went back to Cooper Union in about 2012 to pursue a master's degree. By then they had demolished that old building and built this new one, the funky dented air conditioner looking thing that you see there. That's not a slight. I mean, it's a great building, designed by OSS Tommy. So part of the reason I wanted to go back was like at this point I was kind of into buildings, and I built this new one. It had some great features like cogen system, some radiant heating and cooling. Just again, the weird shade screen that you see, that actually has like some interactive element, or not interactive, but active like openings in the facade for that would, you know, help shade or passively cool the building. So so part of my master's was to develop a calibratable building model of that building. It took about 4 years because I was simultaneously working at my second modeling job, but I got a lot of experience modeling this building multiple times, getting a lot of really detailed data and access. Of course, like I was a student in that building, and I was able to, access the controls and the equipment and things like that. So that was really good experience. And this kind of started my first return to using programming and modeling, or my introduction really. This is an early use of Open Studio for me. I'd say I modeled it multiple times because I literally I modeled 90% of the building using ISVE, and then ran into an issue that I couldn't model it at that point, and had to start over using Open Studio at that point, kind of teach myself Open Studio, and then in the course of modeling this building in pretty exact in detail, discovered that at the time the Open Studio application was pretty limited, even more so than it is, and so I realized that I had to explore using the SDK to really get the most out of this tool and to make my life easier for the building. So so what you see here is just some diagrams I put together of the systems, and then because like I said, I had a lot of access to the building, a lot of meter data for submeters. I was able to do some pretty detailed data processing of that in order to actually generate schedules for the model based on the meter information, and then do kind of a couple different calibrations to that existing data as that thesis. So like I said, great introduction to that, really kind of cut my teeth in the tools. Work experience, like I said, the Stephen Winter Associates kind of happened in conjunction with that master's thesis. My first job at Green Building Services in Portland really taught me energy modeling. I was doing a lot of lead models, all with eQuest Go to. I think maybe a lot people learn with eQuest. It's kind of it's a good intro tool, and for lead modeling, comparative modeling, it's all right. But then it had some I guess key workflow issues that really started to drive me away and into something more flexible. At Stephen Winter Associates, kind of continued the same thing, started doing more code compliance, sort of incentive modeling, started using other tools like ISVE, was doing a lot of big buildings. Obviously New York, we were working on super tall residences, big hotels, this high-rise passive house at Cornell Tech. That was a fun project. Started getting really limiting in what sort of eQuest offered, or at least in terms of workflow experience. So a lot of manual copying and pasting, or data entry, and then again it was consulting, so it's kind of you're kind of behind the curve in where the design is, and having to do a lot of catch up. I'll talk about some of those issues as we go. 2015, I moved to Denver, started working at Ambient Energy. That was more, that was when I was really getting into Open Studio, which is great because that was sort of in the neighborhood of NREL. Started getting some work with actually helping to develop an early iteration of Open Studio standards, and but also doing a lot of energy modeling. Office campuses, Denver Airport, University Labs, a lot of, again, really sort of highly data intensive models. And then for LEED, which, has this whole process for model documentation that again involves just lots of taking model output, doing a lot of post processing on it in spreadsheets, dumping it into other spreadsheets. All this experience is just like sort of like the origin story of how I got really frustrated with modeling workflows as without like using custom tools and really like the sort of programming environment by Open Studio. So at Ambient, we started doing sort of internal tool development to help make that process a lot easier. And then in 2018, I moved to KW Engineering. Pretty much stopped doing lead energy modeling at that point, thankfully. But the job kind of shifted to doing still a lot of modeling, but for a large tech company retail portfolio that they had pretty much like their own energy standards, similar to LEED, but we basically wanted to model all of their worldwide high performance retail stores against pretty exacting standards. This really presented opportunity because it's like different, similar but different, but because the buildings had a lot of consistency, but within that consistency still like a ton of variation. It really helped sort of crystallize the custom tool development process where using Open Studio, we could really develop like a framework for building these models rapidly and consistently, and just providing the client with a really good product that was also like relatively inexpensive because we could like churn them out quickly. Also did a lot of utility incentive analysis. We're here for Idaho Power, SCE, RMP, those things, and lots of other stuff. KW Engineering is great. They do a ton of stuff in refrigeration and utilities, things like that. So it's a good experience. And then last year I started at the lab, really just doing more Open Studio development stuff. So anyhow, so that gets me to like why we should bother trying to learn coding as a BEM practitioner. Again, like I think I'm coming from the perspective that like me, like BEM practitioners maybe started with these tools that aren't so user friendly or kind of single purpose, and then they find themselves in situations where, because of client demands or just project demands, like they're being asked to do things with the tools that they're not really meant for, and so it causes a lot of frustration and friction in the whole process. So in terms of why bother, like in my mind, building energy modeling is basically necessarily involves like multiple manipulations of data and transfers of data between different practitioners in different disciplines. All of them have their own different terminology and areas of focus, and between softwares that might have various formats and no kind of universal shared standards, and then really from like translations from design language into model simulation language, and then back into design language or action. So like in that context, there's like BEM is used, for multiple different things, like comparative modeling, existing building modeling, utility incentive analysis for various upgrades, just lots of things that make using off-the-shelf tools kind of difficult at times, and it really like it yearns for kind of a flexible approach that can help make the BEM practitioners' lives easier and help them be more efficient and innovative. And so that's why that's kind of what drew me to using general purpose programming tools in the BEM process to help sort of mediate all of those like data transfers and then like be really adaptive to various client demands. There's this XKCD comic about how long you should work on something to automate it based on how often you do it and how often it shaves off. I really like this because if you're thinking about like learning a new tool or sitting down to like write a piece of code to make your life easier, it's really helpful to kind of put that in context, put that time in context of like what you're going to save over like a 5-year period. Really for a lot of like the BEM work that I do, I found myself sort of in this range where, you know, the task might be an hour or half an hour or longer, you know, up to a day. And I don't do it that often, but, you know, even at like a monthly frequency, if it saves me half a day, that's like 2 weeks that I could spend over, but that before it becomes, you know, not worth the time so much. So I just want to share this because this is like a nice way that I felt of thinking about, especially if you like have to, I don't know, justify like to somebody why you would want to take the time to like do some coding instead of like actually just move ahead on the task at hand, or to, you know, build a framework that will help you, you know, take a schedule and populate a model from it. This is like a good way to think about that. So, and then like why Open Studio? This is some content that I took from NREL slides. But yeah, it's used as Energy Plus, which is like very a powerful program for doing BEM. It has, you know, many features, but it's like very input intensive, right? Open Studio, you might know it from like the Open Studio application as a graphical user interface for Energy Plus, which is kind of how it started, and that's great. But the real power of Open Studio is in the SDK for writing software to automate those BEM workflows, and it's kind of unparalleled in, I think, the BEM software ecosystem in what it allows you to do with some tools, because the SDK basically, you know, it accesses every part of the model in every way for creating, you know, from creating geometry to inputting data, your HVAC systems or spaces, or basically like at every point of the model, you can do whatever you want with the Open Studio SDK. And because it sort of encapsulates those processes in code, it makes, you know, creating workflows that are repeatable and, you know, reviewable and everything, like very easy and efficient. So that's what drew me to Open Studio. A lot of people feel the same way. This is kind of a summary of different tools that are based in or using the Open Studio SDK for various purposes. This kind of underscores that you know, again, different BEM tasks or different BEM workflows could all benefit from this the open approach that is used by the Open Studio SDK. I've been involved in now 2, 3 of these projects, which is pretty cool. And then the other great part about Open Studio is it has this whole ecosystem of code that exists using the SDK for various BEM purposes. That it's all open. You can all go get GitHub repos for these things and start using the capability, in your own custom scripts to do whatever you like. One of them is Open Studio Standards, which has measures and content for creating ASHRAE prototypes, 90.1 PRM baselines, and then typical models with like a diverse set of inputs. CompSoc is the project that I'm working on now at the lab. That we basically use Open Studio Standards and a lot of input data to generate hundreds of thousands of models to represent the U.S. commercial building stock. And using Open Studio Standards measures, we can account for like the whole diversity of inputs that are needed to statistically represent all of the commercial buildings. Not model them, one by one, but model buildings that, model a set of buildings that are in some representative of all of the commercial buildings. So like this shows, those inputs are like a combination of space types, combination of operating hour, like descriptions of operating hours, loads, HVAC, efficiencies, what have you. This is all available to use and is super powerful for just like a wide range of BEM tasks. In addition to that, the Open Studio analysis framework, has a bunch of algorithms for running, large parametric design optimization studies, calibration workflows, things that are really difficult for an individual person to sit down and make all of the models to do. You can instead create this analysis using the Open Studio analysis framework that connects to all these other tools that can run the kind of algorithms in order to generate this like large scale analysis. So again, just the ecosystem is out there to be useful for many, many different purposes. All right, so I'm often asked like how to get started. Like I kind of alluded to, I kind of came at this sort of in a self-taught way, really just by looking at code that's available online. So anyway, if you're new to programming, this is kind of the course that I took, which is, get acquainted with the basics. Some of those concepts from like my intro to CS class stayed with me really just on, data types and things like that. The thing is, like, to use OpenStudio SDK, you don't need a lot of programming. If you looked at like 2 chapters from this computer science programming basics Ruby and programming basics in Ruby book, that's basically all you would need to know. It's a pretty low barrier to entry. Also, OpenStudio is moving into like the whole SDK is available in Python as well, which is like a more widely used programming language. You don't have to learn Ruby if you're familiar with Python in other contexts. I actually like working in Ruby. I do both now, and Ruby's kind of great. It has some quirks on getting it up and running, but it's really nice to use. The other thing is just find a problem that's out there. It could be a problem in your workflow that you've identified. Like I said, in my experience, a lot of problems came up with, this task is tedious. How can I make this task less tedious? And writing a bit of code to like loop through all of your Fancl units and update them based on a CSV file, like, is a lot less tedious than scrolling through a table in the user interface and typing stuff in. So like, that's basically right. Like, start simple, find a problem. Unmet Hours is a website where people post questions. A lot of those questions are pretty simple and can be, answered with like a little bit of Googling of a problem. And I did a lot of that early on. It's a great way to learn. reading code, I felt like was probably the best way to learn, just like reading, and then making edits and running things and finding bugs, trying to fix them, like reading, like actually paying attention to the standard output of a script so that you can find that line that it's erroring at, go look at that line, think about what it's doing, why it might be causing an error, and fixing it. And then, yeah, keep going. Just like if you solve a problem, store it away for later, go solve a different problem. If you encounter that problem again, you can always come back and you have a solution for that, or like at least a start on that other solution. If you're new to BEM, maybe like you do have sort of some programming experience, but like you're new to building energy modeling, you start by learning the engine. Energy Plus has a great engineering reference that not a lot of people read, but it's actually like interesting reading if you get into it, or if you like me, I don't know. I like read most of it. It's pretty critical if you're like using the tool to kind of know what it does, and that explains what it does. To try things out, like so here's just a snippet of OpenStudio SDK methods. Oh, I should mention, like 5 years ago, I gave a talk at BSUG on the OpenStudio SDK about using it, how to like find this documentation, how to read the documentation. It's available on YouTube if you're interested. That's probably like this should have been the first presentation, and not the second one. But anyway, do things out of order. But yeah, try things out. Like there's all of these set methods are for like changing aspects of this is for a unitary HVAC system. So there's a bunch of control types, read what those control types do in the engineering reference, make a model, and then set them to different stuff, and then run it, and then look at the outputs. I find that you can't really learn BEM without seeing what it does. This is like another thing that really drew me to Energy Plus. Like for the most part, all of the BEM tools that I've used have some form of detailed output reporting that you can look at. In this case, like the node level or the component level to see what the load looks like over a day, what the system flows or air states are like. But I feel like Energy Plus is it has everything. You can request whatever output at whatever system node and plot them all. Start thinking about, does this make sense for or how a system would operate, and use that in an iterative process with the trying things out to really nail down how your model is behaved. I mentioned in my past experience that I've done sort of a number of model reviews, and it's kind of shocking, like when you start digging into models, people like to submit things where they clearly haven't looked at the output because things just aren't working the way they should. And yeah, you can't just like throw something together in a user interface, run it, you'll get some colorful output, bar charts or whatever, and you can't like just assume that that's fine. You really need to be looking at, especially if you're modeling something new, really looking at what is happening in the simulation, well, down to the time step or hourly level. All right, so some examples of, again, like some workflow difficulties that I found and then solved with some scripting tools. So what can you do? You can, like I said, connect your data. This is kind of a process diagram of like previous modeling workflows that I've used, again, for comparative modeling for the most part, where you have your design info, your drawings, schedules, You might, take that into a spreadsheet to organize it, do unit conversions, et cetera, put it kind of into that model language, and then do a bunch of manual input into your model, like creating systems, clicking on the components, putting in your airflows, what have you, like for the whole thing. And then you get your design energy use, then you go look at your baseline rules, interpret a bunch of baseline rules, manually create a baseline model, take the results from your proposed model and your baseline model and copy them into a spreadsheet and maybe do some post-processing that way. But each of those red arrows is kind of like painstaking manual steps. When I was at Ambient Energy, we tried to start thinking about this differently and how we could use the tools, and came up with something like this, where we have our design info. We still need to translate that into model info, get it into like a spreadsheet form. But since we're using a spreadsheet anyway, and we had access to the OpenStudio SDK, which could just take data from that spreadsheet and go put it right into a model without a bunch of manual entry, started developing this spreadsheet-based tools. And by spreadsheet-based, I mean, this was tied into the OpenStudio SDK with like a very simple VBA script that would do a system call to run a Ruby script, which would then read data from the spreadsheet. With that data, go create or edit the model elements. It could access that OpenStudio standards gem to pull in the baseline information, create the baseline model, and then write a bunch of output data, like run the simulation, write a bunch of output data to the spreadsheet to generate the report. So this basically compressed the whole modeling workflow from a bunch of manual steps into, I guess, 2 manual steps. One is putting the design info into a spreadsheet, and the second one is to press a button in the spreadsheet to do the rest. So this was kind of like a really like mind expanding change for me. This involved creating a number of custom libraries for reading from a spreadsheet, for processing into an OpenStudio model, running the models and things like that. A lot of that code now, not the same code, but equivalent code just exists in OpenStudio standards, again, for creating baselines, running models, all of that stuff. So yeah, this was kind of an early attempt at improving workflow. You can quickly handle very specific changes that aren't, again, based in the model language that you need. So this is an example where this is in kind of an early stage model. There's not a lot of space type info, but what the engineer could provide was outside airflows at the building story level. There's no building story level outside air input into OpenStudio. You would have to break those into space level ones, which is basically what this piece of code does. Gets all the building stories in the model, loops through all the spaces in those building stories, gathers up the total floor area, and then uses the data from the flows hash based on building story name to set the outside airflow rate at the space level design specification outdoor air object. It takes 5 minutes to write this piece of code. It can be updated if the engineer comes back with, oh, we've changed our building, our outside air assumptions, and now the totals look like this instead of this. Just copy that data in, run it again, it'll change the model. Now your model is aligned with engineering assumptions at SD, which a lot of times they're not, and that creates a lot of differences in expectations, I would say, with how the building should be.
Hey,
Um,
Eric, we have a
yes.
question online.
Okay.
Did you still have to model the geometry separately? If not, what type of information would be put into the Excel spreadsheet to help generate the geometry correctly?
Yeah, this workflow actually did involve modeling geometry separately, but it basically what I arrived at was you would have a geometry model that was just that, just spaces, or maybe a list of space names that could be referenced in the spreadsheet. And then the spreadsheet could go, grab that model, populate it with all of the information that you would need, and then see the run. This was really great because, changing geometry, at least with Quest models, with other tool models is a huge pain, especially if you have all of this other building information associated with that geometry that also would need to be changed. But sort of decoupling the geometry representation with like everything else in the model is what's a pretty powerful concept, because if something in the design changed, it was really easy to go update the geometry model and then rebuild to the whole thing. This workflow, yeah, also introduced to me the idea of like just not keeping one model file and then like going and having to update that one model file for any little change that would come in, but basically like rebuilding the whole thing, because like building the model is now trivial. It just takes like pushing that button. I mean, like populating the model with all of the information that it needs to actually be a model. So it was, so you could just, start from scratch with basically no issue. Yeah, and then, but anyway, so some geometry, again, because Open Studio has access to every part of the model and you can do anything with it. This was an example where I was modeling a building that was dome shaped, and it had windows all around it. And because it was dome shaped, in order to draw the window, like the windows need to be coplanar with the surfaces. I could have gone in and drawn on each of, so that it's dome shaped, like Energy Plus doesn't deal with kind of curved shapes. I approximated it with, with flat planes, but still wanted to kind of give the whole approach. Anyhow, so it just came up with like an algorithm for creating the windows based on the geometry data of the surfaces. So like starting from top left, like go find the first vertex of that surface, get the vector to the next vertex, scale that down to, I had a bunch of data actually on like the dimensions of these windows relative to the surfaces, which was great because I could just load up that data and then apply it to this algorithm where you're scaling the vector, getting the vector to the other surface, scaling that, adding the two vectors, which gets you the summation, which points to where that window vertex should go. Run that 4 times for each vertex of the surface, and then you have the array of vertices that define that window. Go create that window object with that array of vertices. That was a way that, for like a hand of like 500 or so, I don't know, 300 surfaces, you could just go create, individual bands of windows for all of that. Again, fairly trivially. So it's another fun problem to solve. That's actual building, by the way. Pretty interesting. You can use like all the features of the tool. The thing with like using the Open Studio application, it's great. But for something like an HVAC system, it's limited in kind of the combination, especially for like a unitary system, which is really a virtual component. It can basically hold different arrangements of cooling coils and fans and have different control aspects. Anyhow, this is basically like an input layer that I created kind of on top of Open Studio input. where this data structure is kind of like JSON formatted, or number of arrays and hashes of key value pairs, would be fed into a big library that would make an air loop with whatever information I put in here. And it was modular, so that these coil components, I could swap those out with different ones. I could use water coils instead of a 2-speed DX, or different fan objects if that's what the design called for. Have any kind of input that I wanted on COPs or flow rates or anything, or if that information wasn't in there, it would just auto size the component. This is the kind of a tool that I made at KW for that, the retail client, that enabled us to handle the wide range of diversity of HVAC systems. And I'm talking like worldwide diversity, different design teams from all over the world that would do their own things specific to their climate, on system types, on controls, on energy recovery or not, or economizer control or not. And so being able to define all that input in like a modular way like this, super powerful, really helped us get a lot of that efficiency out of modeling. You could just automate the whole simulation. This is a GIF from my friend Julian, who has this up on GitHub. This is a use of the Energy Plus Python API, where in a Jupyter notebook, you can go call that Energy Plus API to run the Energy Plus model, and then dynamically output or populate this, basically a plot of output. So that was like generated live as the simulation progresses. And then also while that's happening, calculate other kind of metrics from the simulation, because basically every time step, it can get those values out, do additional calculations, and then say like, stop the simulation if it's determined that something's wrong, something like that. Again, there's like the amount of the ability here is very vast. And then even like automate the automation. Open Studio has this thing called measures, where you write like a measure as a piece of Ruby code. It can be run on the model. I wrote this function that will just apply a measure to a model. So I have the measure as a file. I just pass it some data as the input, call that function, it'll go run that measure on the model. This one was to run this create bar from building type ratios. That's the pretty critical measure in the Comstock workflow, to create building geometry, like whole building geometry with simple inputs on aspect ratio, height, number of floors, window wall ratio. To create kind of simple box models, but then they are populated with all sorts of information. And this actually doesn't have to be run as a model or as a measure. The code to do this, again, exists in Open Studio standards. I didn't actually have to write this apply measure to model function. I could have instead just loaded up the Open Studio standards library. And well, it's kind of new that that standards has this capability, but now I wouldn't have to use this. I could just call a method called create bar, pass it this information, and it would do the same thing. And then finally, you can like output any and all of the data, automate that output, create kind of detailed reports on a bunch of options. This is again looking at locations around the world for your retail store, various dimensions of awning, and then outputting things like what the maximum solar gain on that front window is, the number of hours that it was above a certain amount, and various heating or cooling load operations. Like to put this analysis together, including building the models, running them all at all of these locations, outputting all of this, like finding this output, putting it in a big spreadsheet. It's like, I don't know, 2 or 3 days of work. But not something that I would want to do without like writing a script to it. So yeah, summary. The open source BEM tools, Open Studio, just provide numerous opportunities to learn and develop custom tools to answer a variety of questions and really help out with your workflow and help deliver good results to your clients. It's my backpacking. That's all.
Thank you,
Thank
Eric.
you.
Number of folks online. Dylan, I'll let you handle the questions there. Dylan's just the Wizard of Oz up there, upstairs, managing things. But then for the folks in the room, we've also got a feedback form if you have for feedback for the lab. Today's computation, if you wouldn't mind filling that out. Like questions for Eric and how to get his genius of programming into your workflow. And don't forget to mark your calendars for June 12th for next week's. Eric, this was impressive. And I would recommend also going to our BSUG YouTube channel where you can see some of these tools kind of in action that you did a number of years ago and how you automated a lot of different workflows. So do you still use the OpenStudio interface at all, or are you just kind of doing an all SDK?
I will still load in models into the OpenStudio app to like look at them. But at least, yeah, when I was at KW, I was not building models in the app. It was pretty much all happening within the custom tools. Yeah. Actually, like, again, it all started because early versions of the app were terrible. Very slow, limited input that you could do. It's gotten a lot better. They've done a lot of work on it, and yeah, I commend them for that. It's still a great tool, but it is even better if you don't have to use it, in my opinion.
So Eric, if you want to summarize the workflow, what kind of information goes to your spreadsheets and what kind of information you just assign them in the model? You don't assign anything on like in the OpenStudio directly, right?
Right. That's kind of how it ended up. Yeah. Again, what I was describing was kind of different points in like, the last like 8 or so years of refinement through various iterations. But I guess the point is it's entirely up to you, like how much you add and where. And if you are getting started, right, then like I think the easiest thing is like, or a sort of a great way to handle kind of initial like getting comfortable with it is like you have a CSV file, and loading a CSV file is like a very simple task. You can Google how to load a CSV file in programming language of your choice, and you'll figure it out in a couple of minutes. And then creating a loop to go access whatever you want in your model and assign that piece of data to it, is like 90% of all of those workflows are based on basically like that idea, right? Taking a list of data, like matching it to a certain input or whatever in your model, and then like that's like looping through. You might have to match it to a space type or a thermal zone name, a system name, or whatever. But yeah, it's really like that, not much more. And that's why I said like two chapters of an intro to Ruby book is all you need, because that's what it is. It's not genius for sure. Like I'm not a genius. I just like got sick of doing it other ways and felt like thought that it could be better and figured out ways of doing it that were better.
Hey, Eric, we got a question online. How many hours does it take to build, say, a lead energy model using this automated approach?
From like a full CD, like a final model, you know, maybe so the bulk of the time is gathering information from a set of drawings. Again, I've never worked in like at a design firm where I had sort of direct access to design information. I would always be getting things like from a permit set or a CD set. So it'd be like the bulk of the day is gathering information. So I would say like under a week, probably, like a couple days for geometry, depending on the building size, of course. And then like maybe a half a day in just populating the information in the model and, you know, dealing with any issues, and output a report. But like, yeah, the point is it takes all of the time for like input, and shrinks it down to like nothing, basically. It's really just like doing the translation of from that design language into model language, which depending on the design or the data you have available, you know, could be easy or not. And then just running it through the meat grinder. I will say on the topic of like of getting design information, like the skills are like general purpose program skills are great for other ways as well. Like I one example where I was working with an engineer and they had their load modeling tool could output a GBXML file, which I thought was great. Like give me that GBXML. That's going to have all the information that I need to populate my model. I get it, and then it was wrong in some ways. Like I opened it up, looked at it. The crucial information, like the zone names, were kind of in comments in the file instead of like where they should be in the proper XML tags. And we're talking, you know, hundreds of zones. But like having that text file, at least I could, you know, find a XML parsing library, or actually, I don't even think I used an XML parsing library, just like read lines into a text file, found the comment flags, was able to like extract out from the comment, like the lines with the comment flags, what those zone names were, like where they were in the XML file, basically like reconstruct that into something that I could then use. So yeah, like having a little bit of skills, like using a general purpose language, not just is beneficial for, you know, building models, but also for, you know, the whole kind of process of building models, working with the data.
Can you hear me?
Yeah.
With your experience, like on the private sector and also doing the energy modeling coding, what would be your elevator pitch for people who are debating between spending the investment of the time and doing their own, getting in that deeper level of model knowledge versus like relying on more private sectors to do the modeling and then come back with more information? Like you spend less time overall and get the input they give you, but you have less in-depth knowledge yourself doing the coding. What would be your elevator pitch for the way you do it now?
It's a good question. I'd say like I guess it depends on how valuable it is to have that competency in-house. Like if you're doing that type of work all the time and it is, you know, it's expensive to outsource it. That goes back to the XKCD like comment, right? Like there's a point at which it become like the economies of scale or whatever kick in, and then it becomes really easy. So if you're doing a task a lot, and it's relatively like expensive to farm it out, it is really worthwhile to spend the time to do it. So it's hard to do a pitch like with you know, just that vague question. It really depends on the circumstance of like what it is. So I found, you know, I was fortunate enough to work at companies where like they, you know, my managers kind of understood that like it would be over overall beneficial to invest in the work in building these workflows, and because, you know, like a lot of the problem with BEM and consulting is that, you know, it takes a long time to do it, and especially, you know, and like, again, you're like following behind the curve of design, and they want answers, you know, like for the permit set, but you don't have those answers until you get the permit set, and then you can go model it, and then like 2 weeks go by before you can, you know, generate a report to give them or whatever. Like ideally, you want to be a lot tighter to when decisions are being made with your answers. So like we were able to, you know, convince the people that mattered that, like, again, investing the time in this would make us more responsive to clients, reduce the cost of like doing our work, which means more profit for the company, and then also because like we're bypassing all of this manual entry and manual calculation and things like that, the output would be better, right? The model would be more consistent. It would be, you know, we could sort of handle more of the details that are often forgotten if you're doing it manually, like, oh, I forgot to like update that wall construction or whatever, and now like the model is wrong, and you're getting a review comment, and you have to like go do that all again. You can just like put all that in the code in the first place, just review the code, make sure that like this is going to do the right thing, and then have it go. So hopefully that helps.
Can you help us understand how much of this workflow is what the IDL provides versus how much, you know, is there like a consulting fee? I'm trying to understand how this fits into what we do in the private consulting world.
This is kind of my my like psych up pitch to you to like do it yourself.
Okay.
like none of the workflows like that, you know, I did for my company is, and they use that, and I don't have access to it anymore because I don't work there, you know. But the point is, it's like these are tools that are like Open Studio is available. Like all the Open Studio standards code is freely available. All it takes is like a little bit of effort to, you know, learn those programming basics, get comfortable with like using that stuff, like reading the code, understanding what it does. And then again, which is not like rocket science. It's just, you know, pretty simple stuff. So like when I was starting like learning Open Studio, they're like, oh, there's this thing called measures, which you can, you know, use to change your model, and all it takes is a little Ruby code. And I was like, I'm not gonna do that, right? Like I'm not like a programmer. I got a C in CS, like, but then it wasn't until like I sat down and I was like, oh geez, like I can, like I would really like to do this complex task, not too complex, and like maybe I can figure it out with like a little bit of thing, do it, and you're like, this is great. It's because then it's like, this is magic, right? Like I just saved hours of my time with not a lot of effort. So yeah, this is like, I'm just trying to explain to you that that this is worth doing if you're a BEM practitioner, because they're like, and you know, your mileage may vary. Maybe you don't have a lot of issues with your workflow with off-the-shelf tools. That's fine. Maybe you pay for BEM tools that, yeah, are like totally fine for workflows, and you don't have any use for this. I would still say like it's useful to like know some programming, like to help, you know, sort of bridge the gaps where they're like, you might find that you're doing things manually, or taking a lot of time to just do like simple data entry stuff. Like nobody wants to do, like we shouldn't be doing data entry. We should spend that time doing like what is fun with BEM, which is like helping buildings improve. So So yeah, and then it helps you in, you know, I think be a better modeler, be a better engineer or BIM practitioner in order to have these skills. So that's kind of like the bottom line of the talk.
Yeah, I'd say on the IDL side, you know, we done limited scripting, but every time we've never regretted it. For example, like creating a text file that has local utility rates that we can then just reference anytime we run a model, so we can look at the return on investment of, say, adding a different window film or something like that. And I don't do as much back-end work as Eric does. I still use the app and the graphic user interface. But even just downloading it a little bit, I would just, second Eric's point that it can be really valuable if it's something that you revisit. And I never had a programming class either. Stuff, which is probably a tragedy. But just using a little bit of it, you don't need to be an expert in it or a genius. And it feels like magic, like you were saying, and it just saves hours of time in the future. So we can, as IDL through Power, help you on your way, hopefully. But then it's an open role.
And what program do you use? Do you use Python or the Ruby or both of them to be able to, you know, as the program that modifies your model?
Yeah,
And which one would you recommend for new users who haven't gotten into this?
either really. Like I think, well, so the Python bindings to the SDK, like the SDK being available in the Python language, is relatively new. They're like the version of OpenStudio that's coming out in the next month or so. It's going to have like the measure capability, so you can write OpenStudio measures in Python, whereas previously it was only Ruby. And it's like it's just like way more widely used in all sorts of things. That has tons of libraries that can support whatever. There's like a great psychrometrics library in Python that you can like incorporate into your stuff. So maybe Python. I started with Ruby because that's like when I was getting into using the OpenStudio SDK, that's kind of the option that was available. Like I said, I like it a little more, like just writing it, like it is kind of a nicer syntax in my, or maybe I'm just used to it, but I don't know, dealer's choice. I'd probably go Python if I was like starting out, because there's probably like just more out there available for learning and things like that. But it's a little bit newer into the OpenStudio ecosystem.
Thank you very much, Eric. Really appreciate it. Best of luck on the next ride back.
Yeah, thanks.